My name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we're about to solve are the ones that you will find on page number 151. Please turn to it. Page 151. And today is our lesson number 271. Page 151. The very first problem that we see there, problem number 3. This is the same problem that appeared in the first edition of the book, first edition of the revised GRE. We have already solved all the problems from the first edition. This is the exact same problem. All of these problems that you see on this page, on page 151, are the exact same problem appearing on the exact same page number on second edition as they appeared in the first one. They have already been solved. If you're interested in watching the solutions to these problems in more detail and in depth, you can watch day number 39. Here, we're going to read the problems, but at a little bit of a faster pace. So here's a picture that is given to us. We are given a circle, and we are told A, B, C, and D, something to this effect. Now they do not tell us, nowhere in this picture they give us the center of the circle, so we can't really tell how these points are located at all. There is no way to actually pinpoint the exact location of these points. All we are told is that we have a quadrilateral ABCD inscribed inside the circle, and we are told the diameter is 10. Column A and column B. Column B is very straightforward. We have a quantity of 40, and here area of the quadrilateral versus 40. What can we say here? What is the maximum area that this quadrilateral can have? Keep in mind, always you must keep in mind that unlike the good old days, many moons ago, when we were little boys and little girls, and when we took the SAT in the high school, all the pictures on the SATs were drawn to scale. All the pictures on the SATs are drawn to scale. GRE is just the opposite. Pictures are not drawn to scale unless it actually tells you in the caption that it is drawn to scale. This picture is not drawn to scale. Since it's not drawn to scale, there is no way for us to ascertain the exact location of ABCD. For all we know, ABCD could very well be located such as this. Here is our circle. Here is our center of the circle. And for all we know, they could be located like this. What will be the area of this quadrilateral? This is the maximum area. This is the maximum area that this quadrilateral can have. Now if it turns out that the maximum area that this quadrilateral can have is less than 40, then of course the answer is B, because even if they were sitting like this, the maximum is less than 40. But if it turns out that maximum is something other than 40, something more than 40, then we have a problem. Let's find out, shall we? So here's our point A, B, C, and D. In this case, the area of triangle BCD, the area of the triangle would be 1/2 base, which is from B to D, times height, which is from C to O. C to O, of course, is the radius, which we know is 5 because we are told the diameter is 10. So 1/2 base, which is B to D, which is the 10 diameter, times the 5. If you divide top and bottom by 2, we find out that the area of the triangle BCD is 25. 5 times 5. 5 times 5. That tells area of the bottom triangle BDA will also be 25 because it's symmetric, obviously. That tells us that the maximum area that this quadrilateral can have is 50. I need the room, so we need to erase it. Maximum will be 50. talking about this column A here. Maximum area of the quadrilateral is 50. But we have no way of knowing where A, B, C, where these 4 points A, B, and C, A, B, C, and D are located. Area of the quadrilateral, for all we know, area of the quadrilateral could be 50. And since this is 40, in this case the answer would be A. Area of the quadrilateral, depending on how these points are located, could very well turn out to be 40. And since this is 40, the answer would be C. And area of the quadrilateral could very well be something less than 40. It depends on where the points are located, in which case the answer would be B. Since we do not know where the points are located, the quantity A could be bigger, quantity B could be bigger, or the two quantities could very well be equal. And therefore the answer is D. Therefore the answer is D. There is no way to tell what the area of this quadrilateral would be, because they do not give us any location at all of these points. They do not give us anything at all to pinpoint, to locate these points A, B, C, D. Let's move on then. Problem number 4. That's it, we are done with this one. Like I said, if you need to do the same problem again at a little bit slower pace, you can go back and watch the original video, which was on day number 39. The next problem that we're going to do is something that we did on day number 40. Problem number 4. In problem number 4, they tell us that x squared times y is more than 0. They also tell us that y times x squared is less than 0. Okay, now listen what happens. Listen what happens. Since x squared times y, we are told, is more than 0, since we are told that the product of x squared and y is greater than 0, is positive, but we already know that x squared, no matter what x is, whether x is positive or negative or fraction or whatever the hell it is, even if x turns out to be negative, the square of any quantity will always be positive. X squared, we know, is positive. That's for fact. That we know for a fact. Since x squared we know is positive, and we are told that when we multiply that by y, we get a positive quantity. That implies that y must also be positive. Y must also be positive. Since this is positive, y must also be positive, because positive times positive is more than 0. So we find out that the y is positive. Now let's look at this part here. Again, we know that y squared is positive. Regardless of what y is, y squared will be positive. As we are told that x times y squared is negative. Some quantity times some positive quantity is negative, then x must be negative. So from here we find out that x is less than 0. From here we find out y is more than 0. Y is positive and x is negative. In column A, we have x, and in column B, we have y. Y we know is positive, and x we know is negative. And therefore positive quantity would be bigger, obviously. That's it. Let's move on then. Number 5. You don't have to sit there and waste your time plugging in numbers, just think logically. X squared times y, we are told, is positive. If x squared times y is positive, x squared we know is positive. So positive times positive must be positive. Y would have to be positive, y cannot be negative. Otherwise, x squared times negative quantity would have been negative. Let's move on. Number 5. In number 5 we are told that we have 9,000 spectators. We are told that X are from college C and we are told that y are from other colleges. Now let's see how did we gather all of that. It says among 9,000 people attending the football game, so 9,000 is the total number of spectators, as you can see there. We are told that there were X students from college C. There were X students from college C, and Y who were not from college C, and Y who were not from college C is another way of saying that there were Y students from other colleges, Y from other colleges. And in the first column we are asked to compare number of people attending the game who are not students. Number of people who are not students. Well, how do we figure out how many people out of these 9,000 are not students? Well, that's very straightforward. We have a total of 9,000 minus the number of students, which is X plus Y, minus the total number of students. The number of students from college C is X, and number of students from other colleges Y, so it's 9,000 minus X plus Y, which is the same as 9,000 minus X minus Y. And in second column, in column B, they give us the exact same quantity, 9,000 minus X times Y. 9,000 minus X times Y, exact same quantity, therefore the answer is C. Now if you wanted to, you could plug in numbers here, but it's not necessary. Let's move on then. Number 6. Problem number 6 is something that we covered on day number 40. Problem number 6. We are given x times x squared cubed over x squared. They simply want to see if you know how to manipulate simple exponents. That's all it is. As you can see, there's not much in there. So we have x times x cubed, rather x squared being raised to the third power, which is same as x squared times x squared times x squared. X squared times x squared times x squared over x squared. So one of the x squared drops out, and we have x times x squared times x squared. We simply add up the exponents. We have 1 plus 3 and then 5. So it is x raised to 5. That's it. I will see you tomorrow when we'll continue our journey, and we'll tackle the problems that you see on the following page. Let's see what do we have on the following page. Ah yes, some nasty ones on the following page. We'll do those tomorrow. Alright, bye now.